Welcome back, everyone, to another episode of the Engineering Future Podcast. I'm your host, Luis Duque, and this week I bring a conversation with Mike. He is doing some amazing work with underwater structure inspections. We get a little bit in the details of the inspection, maybe a little too technical for what we usually talk about in this episode, but it was a lot of fun just to hear his perspective on how to approach these kind of really technical challenges and really unique problems in engineering, and use kind of the base knowledge that you have and apply your skills and your capabilities and everything to these specific problems. So thanks so much for coming for this episode. It was a lot of fun talking with Mike and all the great things that he's doing with the underwater inspection for bridges. And yeah, again, it's a very unique episode. I think is a little too niche for what we have talked before, but I really hope you enjoy it and take something out of it in terms of your career. We also talk about how he found this job that is merging his passion for swimming with his career passion, which is structural engineering. So there's always room to find your career and find your passion within anything you're doing in life. He just gave a presentation a few weeks ago when this episode comes out. I'll link in the description below, and I hope you enjoy the conversation with him. Again, go to the link in the description below for the full presentation, and that's a little more technical than what we cover here. But this is a really great example of some of that fun intersection between his career passion and his hobby and his passion kind of outside of work, and combine the two and just find a really fulfilled career. So thanks so much for coming back to this episode. Again, make sure you subscribe to the newsletter for new content every single week. Just sharing some of the behind the scenes of the podcast, some of the things that I'm reading, learning about, and hopefully bring some extra value to your inbox. Again, once a week, it's a really casual newsletter, and I hope you guys subscribe and give it a try, and hopefully you enjoy it once you subscribe. So without further ado, let's just jump right into the conversation with Mike. Welcome to the Engineering Our Future Podcast, a podcast where I bring you relevant content from personal experience and guests to help young engineers, students, and international students succeed in their careers. Welcome back, everyone, to another episode of the Engineering Future Podcast. Today, I have Mike with me. He's doing some amazing work with inspection of bridges, doing some amazing technology, and I wanted to have a conversation with him and just learn more about what he's doing in his career. Mike, do you want to just give us a brief introduction on some of the things you've been doing and just what you do for your career?
Sure. Yeah. Thank you for having me on. My name is Mike Banasiak. I work for Collins Engineers. I've been there for about 10 years. We specialize in, really to put it simply, structural inspections in difficult to access places. So from rope access hanging off tall bridges to deep underwater, difficult access is our specialty. And so I'm a diver. I'm a commercial diver. I am a rope access Sprat Level 3 supervisor and bridge inspector. Yeah, great to be here.
Yeah, that sounds super cool as a career in engineering, and I'm sure a lot of people haven't really heard about what you do. Do you mind just can us give us a little feel of what you do, maybe during an inspection when you're diving, or what kind of like technology you guys are using when you're doing these inspections?
Sure. Yeah. So, the Federal Highway Administration mandates that every bridge that has substructure units in the water, typically deeper than 3 feet, has to be inspected, has to undergo an underwater inspection or diving inspection every 5 years. So this federal mandate basically opens up the world of underwater bridge inspections. So Collins Engineers, actually, Tom Collins founded our company a little over 40 years ago. He wrote the manual for underwater bridge inspection for FHWA, founded a company right after, and was the first to employ the use of engineered divers for underwater bridge inspections. So essentially, we're diving or wading in the water to examine the substructure units, the piers, the bents, piles, columns, exposed footings, really for the most part for large scale defects related to scour or erosion from high flows from the channel. So essentially checking to ensure spread footings aren't undermined, checking to ensure adequate pile embedment in the channel bottom. From these large scale kind of focus from our inspection to smaller details such as measuring remaining steel section on piles, cleaning piles or cleaning columns for marine front facilities, from aquatic life, and performing NDT, or steel remaining thickness on those submerged substructures. When I graduated college, I had no idea there was a world of underwater inspection. I was a swimmer in high school. I loved the water. I found out about Collins Engineers, and it seemed like a good fit. That's underwater inspection is kind of our bread and butter. We do inspections for all 50 DOTs, but we also branch into marine front work for Navy, Coast Guard, any kind of marine terminal or facility, oil and gas, and so allows us to travel around and kind of get to parts of the country that very few people have been. The bottom of the Mississippi in New Orleans, and bottom of the Chicago River. So.
Yeah, that's fascinating. And I'm a structural engineer, so I understand kind of what it means to inspect some of these structures. And I did my research on inspection of bridges and drones, which was a relatively new technology back in 2016. So it's fascinating to me to see, like, after you graduate as an engineer, there is so many opportunities to be involved in different aspects of the engineering field. And it's really hard for a student to realize how many options, how many career options they have once they graduate. And I just kind of want to hear from you. And this show is mostly geared towards students and maybe young engineers, so you don't really have to get too into the weeds, into the technical concept. But I just want to hear, what was your perspective when you graduated, maybe found this company that does this really unique inspection and engineering, and what would you recommend students do if they're faced with the same situation as you were, entering into a career that is completely out of the scope of your regular class in engineering?
Sure, that's a great question. Because in traditional, I graduated with a civil engineering degree as well. In our program, the field of structural inspection is rarely touched on. You learn design, you learn construction management, wastewater. I mean, civil engineering is a huge field, and as an undergrad, you're touching on quite a bit. But I feel like the world and careers in structural inspection, is not at the forefront of a lot of undergrad programs, is not necessarily talked about. But it's a huge, it's a huge industry. Bridge inspection and structural inspection, and really asset management, is a huge industry with pretty decent job security, because basically every bridge has to be inspected every 2 years. Every bridge on the national highway system has to be inspected every 2 years above water, and like I say, 5 years below water. So, we're running repeat inspections. We have a decent backlog of work for the future. So, but as an undergrad, it's a field that I think not a lot of people know exists. And for me, I'm a pretty outdoorsy person. I'm an active person. I like, I'm a visual learner. I like movement. I like, examining physical objects. That kind of attracted me to structural engineering in the first place. And the active inspection of a bridge, or wall, or signals, or signs. Really all aspects of infrastructure get inspected now. You're out in the field, you're outside, you're working physically, and also you get to see interesting structures and interesting defects. So for those who are it also, there's office work involved, reporting. But for those who are looking to escape kind of the 9 to 5 cubicle life, there's an outlet to use your engineering degree in a way that you're traveling and you're doing physical hands-on work.
Yeah, I think a lot of people don't realize that's the case, and I certainly thought that, especially early on in my career, I was going to spend 40 hours plus a week sitting on a cubicle, crunching numbers, doing calculations. But I was fortunate that the first couple jobs that I had, they were pretty field oriented. Like even I don't know, 6 months out of school, I was already doing like field inspection for residential construction, and it was just fun to go out there, talk to the clients, talk to the contractors, and kind of get to know them, trying to see if what I'm designing is it's also constructible, because that's one of the main aspects that we need to realize as engineers, that doesn't mean that if something is it's checks on the numbers in the design, it cannot be sometimes it cannot be constructed just because of access issues or something else. So getting the field inspection is really important. Right now, I'm working on a company that does like bridge demolition, which is a really interesting aspect of engineering as well that not a lot of people get to do, and it's always fun to. Obviously, I haven't really been able to go outside to decide because of COVID, but when the time comes and I'm able to go outside, just seeing how the design that I put into paper is actually being implemented in the field, and every time I go out there and maybe talking to the contractor, and he says that my design could have been better if I was doing something different. So being in the field is also super important, and students need to realize that that's something that is available for certain careers, and obviously for yours it's probably 80% of the time, because field inspection takes a lot of time and a lot of effort. What are some of the technologies that facilitate that field inspection when you're doing these like underwater inspections?
Sure. Yeah. And you mentioned 80% in the field, and sometimes it is like that. So in the summer, when it's warm out, we're on the road, trying to get the inspections in when the weather's good. But we're out in Pueblo right now, so it actually was great. But for an underwater inspection, it's unique because there's so much logistics and setup that go into the inspection. The small amount of time that the diver is actually in the water. So depending on the facility or the bridge or the waterway, we do bridge inspections throughout the Mountain West. So Montana, Colorado, Wyoming. We're going to be diving in New Mexico in a few months. So a lot of these rivers are mountain streams with fairly variable flow. So if we're in it in July, we might have a jet boat, with a big motor just to get upstream. If we're diving in February, we might be wading across the channel. So access on the site kind of dictates equipment. So we have our basic setup for kind of mountain underwater bridge inspections. We have a dive van with John boat, so a 14-foot John boat on the top. It's kind of quite a scene driving through the mountains with a boat on top of your van. But with inside, we've got an outboard motor, and we've got full surface supply and scuba setup. So what I mean by that is there's essentially two ways to dive. And, you think about old school scuba divers with a tank on their back and that's it. And back when Tom Collins started the company, that's basically the technology that was available. Threw on a tank, threw on a mask and some fins, and you dove in. No communication with topside, no safety lines, no backup air. It was much more cowboy 40 years ago. So now, the standards of dive safety have definitely kind of crept into all industries, and we've embraced that. In that, when we're in the water, we have we're typically in an AGA mask, which is like your full face mask. That firefighters will use. It's a lightweight kind of mask that's oral nasal, and it's connected to basically a communication line that goes to topside. So if you're diving off a boat, we're in a mask. We have communications, constant kind of audio with topside, which facilitates safety, but also, note taking. So, if I'm underwater and I find some undermining, I can give a note, and topside can ask me questions. Hey, can you give penetration or vertical exposure of this footing, or how many piles, or if I'm giving thickness readings, I can give that immediately, as opposed to have to remember it and surface and give the note. But really, it functions as a safety line. We dive with multiple air sources. So we've got a bailout bottle, in addition to our regular scuba bottle, and that's if we're just doing scuba operations, which we really rarely do. We're mostly doing surface supply operations where our air source is, actually on the surface or on the boat. So our umbilical contains a communication line as well as an air line. So topside is maintaining our air and maintaining communication. So the safety, the practices have really kind of advanced through the years in terms of diving, and that kind of goes for all commercial diving. We've embraced that, and it's you can be diving in ripping current or pitch black, and it's much more reassuring to know that you've got a team behind you. You can speak to somebody. You have a standby diver ready to get in the water should there be any issues. That's a lot of the equipment that we use to kind of just promote safety and promote access. And then the other side is the inspection. So like I say, sometimes we might be in rivers or channels that are pitch black. You can't see 5 inches from your face. So the diver, is essentially performing a kind of a tactile inspection, just feeling around, again, for big issues like undermining of a footing, exposed piles, these big scour erosion related issues. But we do have equipment that we'll bring underwater to kind of give us quantitative data from inspections. And I mentioned one earlier. It's an underwater D meter, which is essentially a acoustic steel thickness gauge. So basically, is handheld, can be wrist mounted, and it comes with basically like a transducer on a wire, and you'll press that up against steel, and it will give you the thickness. So typically underwater we might have steel piles that have corrosion or delamination or pitting, and that we might be interested in the remaining thickness for a load rating calculation or to compare over time. So underwater D meter is one of the bread and butter kind of tools we employ. Another piece of technology that we've just started using is an underwater resistograph, which is basically a timber boring tool. And so resistographs have been around for a while. It essentially utilizes, at its core, it's basically a drill that measures the resistance of the bit as it goes into wood. And if the bit goes into wood that is rotted or decayed, there's less resistance. And if it's through solid wood, there's more. But a digital resistograph will print out kind of the resistance as it drills through, say, a pile. And you can calibrate it to different speeds, different boring speeds, different pile thicknesses, and compare over time, rot in a pile. So timber piles underwater a lot of times will rot from the inside out. So from the outside, we might be tapping it with a hammer. Seems fine, but upon using a boring tool, we might find that perhaps 50% of the section is rotted out. So we use them above water, but we just got one for underwater use. So it comes with it's tethered to topside, has kind of a hydraulic umbilical in order to basically keep the chamber dry. But we were doing a bunch of inspections in California for a marine terminal, essentially investigating marine borers, which are organisms that will bore into timber in salt water and kind of eat it from the inside out. And so this underwater resistograph is a kind of piece of technology that allow us to basically look through timber and discover rot or section loss on the interior that might be hidden visually or tactile from the outside. So those are two kind of pieces of technology we use quite a bit for routine underwater inspections. And if you'd like, I could kind of get into the sonar and surveying, because recently we've been, you mentioned drones. We've been using drones, for our underwater inspections to kind of help map the channel. But what type of drone work did you do?
So mine was just your regular like pre-inspection. We had a very limited budgets. We had like a DJI Phantom 4 at that time, which was
Mm-hmm.
one of the newer ones, but it's kind of getting old right
Yeah.
now. Really commercial drone, really inexpensive and easy to fly. We didn't really have any special sensors or anything. I found like a good program. I cannot remember the name right now, but basically create a 3D cloud model of the surface of the bridge or even the whole bridge if we had enough pictures.
Mm-hmm.
But basically, just take the pictures and stitch them together and create like a 3D model, which was pretty cool just to see the damage afterwards and measure cracks and corrosion and everything. And I also wrote like a couple really simple MATLAB codes to find like the entropy and the sharpness of pictures, just to sort through them and find good pictures kind of from a set of hundreds or thousands of pictures when
Thousands,
you
yeah.
take when you're inspecting the bridges. But yeah, just like a Phantom 4, really basic research project, nothing like super fancy or anything besides like the post production and analysis afterwards. Um,
Sure.
so
Pix 4D, was that the program you might have used? There's quite a few, but
um
to like stitch it together for post processing.
Yeah, I can't remember exactly. I know it was something like it was from Agisoft maybe.
Okay.
Um, I can't
There's
remember
quite a few.
exactly.
Yeah.
Yeah, so again, it was like a free trial when we used it. Like just we didn't really take full advantage of the program capability. Just kind of we wanted to see if we were able to gather measurements from the pictures of the drone. So we
Mm-hmm.
basically implemented two methods. One was using the pictures, create the 3D model, and actually doing the measurements directly in the model since it's already scaled and everything from the pictures and the coordinates from the drone. And I found another program that basically does like pixel measurements. So you basically have a known distance, and we have, let's say, 1,000 pixels between those 2 points, and then you just scale it to basically whatever distance you want to measure. Just counts the pixels and it scales the distance. So that's kind of the two methods we used. Um, I was going to ask you, so I have so many questions based on what you just said, because it's fascinating to me that this is even a career a structural engineer can take. Um, but I want to hear from you. Did you know how to dive before you entered this? Do you consider a diver and then an inspector, or an inspector that knows how to dive?
Yeah, good question. Um, I found Collins, and I knew they did diving inspections. Like I say, I was a swimmer. I was a competitive swimmer, loved the water my whole life, but I wasn't a diver. I'd never dove before in my life before I came to Collins. And so, one of the first things I got my open water PADI scuba in Chicago in March, and that kind of set the tone for the dive inspections, because I think it was like 6 years before I dove in Cancun or did a dive for fun. Most of my diving was in Chicago River, Mississippi, bodies of water like that. So I was I was a swimmer first, and then inspector, and then a diver. Collins put me through. I got my open water. I dove for a summer, just to kind of see if I liked it or took to it. Got in the Mississippi River in the Quad Cities, fighting current, and came out of it and still liked it. So
Mhm.
Collins put me through commercial dive school. And so that's kind of the steps that we take with our employees is, we'll get you your open water PADI cert, probably throw you in the water a couple of times. And if you like it, then, commercial dive school is kind of the next big step. And that's where you basically learn the ins and outs of surface supply diving. So with a hard hat, comms, tethered comms, and your air source located above water. And so that's most of the diving we do now is that surface supply diving. So we require pretty much all our teams to be ADCI certified, and that's the kind of certification process to be a commercial diver. So we use Minnesota School of Diving up in Brainerd, Minnesota. Basically, there's two main certifications. Is one, many people know, is your open water diver. So PADI. There's a couple other SSI. There's a couple other organizations that you can get your open water, and that allows you to dive scuba, on vacation. You go to Cancun, you can dive. It's a certification good for life. You basically learn the ins and outs of scuba. The more in-depth certification that we basically put all our divers through is ADCI, which basically is Commercial Dive School. We go up to we use the Minnesota School of Diving, Brainerd, Minnesota. You spend 2 months, at least 2 months up there, learning basically everything from gas law and theory to assembling, disassembling the helmets, underwater welding, underwater burning, and on top of it, you just get a lot of bottom time, so you're diving quite a bit. You come out of that with quite a few certs, but notably, you're an ADCI diver, and so you're qualified to basically be on a team, to perform surface supply diving. And again, we, standards have certainly changed since Tom Collins started the company. It's not uncommon for us to run 5-man ADCI teams, with air, HP compressor. On a boat, with multiple tenders, which are standby divers. So those are the kind of two main certifications. And so the process is you come aboard, you do some structural inspections. We'll put you through your normal open water cert, which is only a couple of days, and then if you like it, if you take to it, we'll send you to commercial dive school, and that's kind of the big certification process to kind of become a commercial diver.
So on top of that, do you also need to get like a bridge inspector certificate, like what's it called, the CSPI inspector?
Yeah, certainly. So yeah, we all take the FHWA courses. So basically to perform underwater bridge inspections, your team leader is a FHWA qualified team leader, so they've taken the 80-hour course through NHI, which is basically a 2-week bridge inspection course. FHWA also offers a underwater bridge inspection course, so underwater team leaders, to be certified as an underwater team leader, you need that training as well. So I always say we're bridge inspectors first and divers second, right? The diving's really cool, but at the end of the day, our job is to ensure the safety of this bridge, and to basically determine and report the conditions of the bridge underwater. So while all the the adventure aspect of the diving certainly attracts a lot of people, we are still performing structural inspections. And that's something, while we do really cool work, we have to remind ourselves of sometimes, because, it's so, it is exciting, and it is very different. But yes, we're all, or at least every team is led by certified team leader through the Federal Highway Administration.
Yeah, that's super cool. Just to think about doing the inspection underwater. I know there's probably a ton of challenges, from the equipment to access to just being underwater in general, trying to figure out where the structure is and everything. What's been one of the most notable bridges you have inspected?
That's a good question. I started working in Chicago, and then moved to Denver about 5-6 years ago. So we inspect all the bridges on the Chicago River downtown. So it's a pretty cool couple of weeks. We dock the boat at the Police Marine Unit at Navy Pier, cruise up and down the river, basically diving all the old movable steel Bastille bridges in the Chicago River. So in terms of kind of cool access and scenery, that's a great job. But I mentioned earlier we do a lot of work for the Navy. And so I've been out to Pearl Harbor a couple of times. We do the underwater inspection for quite a few of their marine facilities there at the Pearl Harbor Navy base. So have inspected a bunch of docks there, and the huge bridge. It's the name of the island, the iconic island at Pearl Harbor is I'm blanking on right now, but there's a couple 1,000-foot floating movable bridge. Basically, that is at the entrance of Pearl Harbor, and the bridge itself is floating on pontoons, and so it can retract, so huge naval vessels can pass through. And so we, dove that bridge and performed an underwater inspection, basically of kind of the floating pontoon area, as well as the piers and the piles. So it was pretty cool to dive, in a location like that, and kind of inspecting an iconic bridge, for our country. So we get to, like I said, we get to go to pretty cool places. It's definitely a massive perk of the job. Diving in Hawaii is great. Diving in the Chicago River, a little less. Like for every dive in Hawaii, we're diving in Farmer John's cow runoff pasture, with pitch black water and a culvert. So, when you picture diving, everyone pictures Cancun, everyone pictures Belize. Not many people picture bottom of the Mississippi River, in New Orleans. So it's not all glamorous, but it certainly is an adventure.
Yeah, I would love to get in all the details and all the technical stuff, but I know you're giving a presentation next week, so I don't know if that's going to be available for replay, but this podcast won't come out before that presentation, so maybe it will be out for replay, and I can link it below or something. So what I want to get into, I don't want to get into all the details of the inspection because it's too technical for this podcast. But if possible, I'll try to link the replay if it's available from Collins, your speaker series that is coming out next week, which it won't be before. It will be, this podcast won't come out before that presentation. Do you want to just give us maybe a last few thoughts on some other interesting things you've done, some other aspects that people may be interested in listening, and just some closing thoughts on all the inspection, all the underwater structure inspections that you have done?
Sure. Yeah. Basically, civil engineering doesn't have to be a desk job, is really the message I want to send out. If you're an active person, if you like, being outside, field work, adventure, there is a way to combine your civil engineering degree to create a lifestyle of travel and what I would consider excitement. All structures need to be inspected. For every cool underwater bridge inspection we do, we're also inspecting traffic signals in Littleton. But again, a job is a job, and not every aspect of every job is all excitement. With underwater inspections, even I say really like 2% of the job is actual diving. The rest is driving the van, loading the boat, loading the motor, fixing the motor when it breaks, fixing the boat when it breaks. Fixing the gear when it breaks. To not get a totally skewed perspective on, when you hear underwater bridge inspection. It's definitely a lot of logistics, a lot of mobilization, but it is certainly a thrill and pretty cool to just inspect and travel to places, that very few individuals have been. I've been on the bottom of the Mississippi River next to a pier, and in my head, I'm like, well, there's probably maybe one other person who's been here before. Certainly interesting. Overall, you can make your career exciting. A career in civil engineering is so broad. Especially structural inspection, that those who are looking for adventure and excitement and outdoors, can be satisfied with a career in this field.
Yeah, and I think the main takeaway I'm taking from this conversation is you can always combine your career with your passion. Like you like to swim, and you had the opportunity to do all these underwater inspections that honestly I did not think it was a career in civil engineering or even structural engineering. So I think my main takeaway from this conversation is there's always a way to find an intersection between your career and your passion, and you obviously found it. And I know a lot of people that have done it, and I also know a lot of people that don't really find it because they are afraid to look for opportunities and new challenges. So I think that's kind of my main takeaway from this conversation. And yeah, it was very valuable just to hear all the great things you are doing and kind of the really interesting way of thinking of these new problems and new challenges of like inspecting structures underwater that I know a lot of people probably haven't heard before. I
Mhm.
just want to ask you one last question. I ask everyone that comes to the podcast, and that it's how can we continue engineering our future?
Oh, it's a good question. I think we need to be constantly um, thinking about our everyday problems and thinking about everyday simple solutions, to these everyday complex problems. Um, to me, engineering our future, you think about advanced technology, you think about drones, you think about underwater scanning, you think about, the extreme innovation coming out. On the other side, we need to be able to look at that technology and use that technology in ways that uh, are efficient and are effective to solve our current problems. So simply innovating, innovation for the sake of innovation is great, but we need to take it a step further and think about how this new technology can solve an existing problem or solve a problem to come, or make a current process more efficient, or more economical. So I think with this new technology and as we move forward, that's something we really need to keep in mind is remaining realistic with our goals and intentions.
Yeah, that's fascinating. And I know, especially when I did my research, it was just incredible to see that kind of this new technology that it's always evolving and always growing, and how we can incorporate that into our day-to-day careers. And it's always just fascinating to see how much this technology also helps our jobs just become a lot easier.
Mhm.
So thank you so much for coming to the podcast. It was just a pleasure to talk to you for these 40 minutes or so that we talked. And I know I have still a ton of questions that maybe we can answer later on, but where can people reach out to you, connect with you, see where you're doing all these inspections, and just overall just connect with you online?
Absolutely. Best place is LinkedIn. My name is Michael, and the last name is Banasiak, Banasiak. So find me on LinkedIn. I do want to promote our speaker series. I'll be giving a talk next week. It's free to anyone. There's a Zoom link on my LinkedIn, and it's a free PDH to those professional engineers who are looking for those. But essentially, it'll be about merging some technology, notably drone photogrammetry and underwater acoustic imaging for scour critical underwater bridge inspection. It's a pretty cool talk, I will say that.
Mhm.
So just wanted to promote that one. But best way to find me on LinkedIn. Our Collins, Denver office is actually hiring right now. So if you are a college grad, we're hiring all levels: interns, graduates, and team leaders. So feel free to reach out. Love to connect with any of you.
Do you know if the presentation is going to be available for replay somewhere?
I think so. Yeah.
Okay.
I have recorded it, and I believe it will be recorded. But it's next Wednesday.
Yeah.
Um,
This
and
podcast
I'll
won't come out before then, so I just want to make sure
okay.
maybe you can send me the link, or we can coordinate, and I can link it below for people that want
Ab-
to learn more about the ins and outs of the underwater inspections.
Absolutely. Yeah, we'll do.
Yeah, thank you so much.
All right. Thank you. Appreciate it.
So there you have it. That's conversation with Mac today. As you heard, he is very passionate about this unique career in civil engineering. And I think my main takeaway from this episode was just finding a career that is fulfilling and that you find brings value to your day-to-day life. If you're someone that is very highly technical and just wants to stay in the office and just work on calculations, there's a place for you. If you're someone that likes to be outside, or like him, that he likes to be swimming, there's also a place to find a career that you enjoy and a career that you can develop into as you become a more senior engineer and as you become kind of more involved in the career and the profession. There's always something. It's always fascinating to me that I find all these really unique careers that honestly I did not think there was someone that inspected these structures underwater. And obviously it makes sense that there's someone that does that, but I didn't realize it was an engineer that is also doing all these other things, kind of outside diving and doing inspections on the water. So it was great talking to him, and hopefully you can check his full presentation in the description below, and hopefully you enjoyed this episode. So make sure you subscribe to the podcast whenever you listen to podcasts, and you will receive the episode automatically to your feed. And thanks so much for coming back to this episode. It's been a lot of fun to talk to these new people and these new guests that have some amazing careers and some amazing backgrounds, and it's always fun to just hear and talk to them and learn from them. Honestly, it's been a lot of fun just to create this content for you, and hopefully I'm just bringing some value. And as always, let me know if you have any other guest requests, topic requests, or anything for that matter. Just reach out to me on social media at Luis Duque EAT. Send me an email, hi@luisfelipeduque.com, or visit the website. I've been writing a lot more, bringing some other people, writing some articles, sharing some great information, some great content on the website. And it's just been fun to kind of have another outlet of creativity where I can share more content and hopefully help you become a better engineer, a better young professional, and just help you get ahead of the curve with this really tough profession that is engineering. And I've just been having a lot of fun doing this, and hopefully you guys are enjoying it too. Make sure to subscribe, Apple Podcasts, Spotify, every single podcast platform out there. And honestly, if you could give me a review on Apple Podcasts, that would mean the world to me. That way we can reach even more people and continue growing this community, continue growing this podcast, and hopefully help a ton more people. If you haven't noticed, this episode are also on YouTube, so make sure you go to the YouTube channel and subscribe. You can find down the description below. So that's it for today. Again, thank you, Jack Winders, for the music, and I'll talk to you in the next one. But for now, let's continue engineering our future.